Okay, so let's unpack this. Have you ever, really stopped to think about how much light shapes our world? I mean, not just what we see, but how we feel and interact with spaces.
Uh-huh.
It's absolutely everywhere, right? A constant presence, yet, well, we often just take it for granted, don't we?
We really do.
It's utterly fundamental to our daily experience, from the moment we wake up to maybe the warm glow of a lamp at night. But there is so much more to it than just flicking a switch on or off.
Absolutely. There's a whole science behind it.
Exactly. So today we're taking a truly luminous deep dive into light itself. We're not just talking about, its existence, but its fascinating, sometimes kind of surprising properties, and how these influence everything from, say, how we perceive a simple red apple to the incredibly intricate ways entire rooms and buildings are designed to evoke specific feelings or facilitate certain activities.
Yeah, the design aspect is huge.
And our guide for this exploration comes from this really comprehensive document. It's titled Light and Its Properties, Artificial Lighting. This source offers a really detailed look at both the underlying scientific principles of light and, importantly, its practical application in our built environment.
What's truly fascinating here, I think, is how something so seemingly omnipresent and simple as light actually breaks down into these intricate, predictable behaviors that we can observe, analyze, and even, manipulate to astonishing effect.
Right, predictable. That's the key word there.
Exactly. So our mission for this deep dive is to truly illuminate, yes, I'll use the pun, it's quite fitting, these predictable yet profound characteristics of light. We aim to understand not only the precise mechanisms by which our eyes interpret it, but also to, really explore the qualitative properties that designers and architects leverage every single day. They use these properties to create very specific visual and emotional experiences within the spaces we inhabit, often without us even consciously realizing it.
Absolutely. And whether you're just, intensely curious about the physics of the world around you, perhaps you're looking to understand your own living and working environments better, or even if you're contemplating a future design project of your own, understanding these fundamental principles will truly give you a completely new appreciation for the light around us.
That shows.
You'll start seeing it, quite literally, in a new light. It's like discovering a secret language that shapes so much of our daily perception.
A language written in light.
So let's kick things off by defining the very essence of what we're talking about here. The fundamental truth, as our source material lays out so clearly, is strikingly simple yet foundational. In order to see anything, there must be light.
Right. Sounds almost laughably obvious, doesn't it?
It does. But this deceptively simple statement underpins everything else we'll discuss. The basic mechanism is incredibly elegant. Light shines on an object, whether it's a chair, a painting, or another person. Then that light bounces off or reflects from the object's surface, and that reflected light travels back to our eyes.
And boom. That's how we perceive the world in all its visual glory. It's a continuous, dynamic interaction happening all the time.
All the time. Silent, constant.
It truly is. It's the silent, continuous transaction happening around us every single second, shaping our visual reality. And crucially, our eyes are sensitive to a very specific kind of light, what scientists call visible light.
Visible light. Okay.
The visible light isn't just one thing. It encompasses the entire spectrum of colors we perceive. Everything from the deepest reds to the brightest yellows, the calm blues, and all the nuanced hues in between. This narrow band of electromagnetic radiation is the portion of light that allows us to interact with the world visually, giving us the rich, detailed tapestry we call sight.
It's wild to think, though, that what we commonly refer to as light is just a tiny, tiny slice of a much, much bigger pie.
Oh, absolutely minuscule.
Because when we talk about light in a broader scientific sense, we're actually talking about electromagnetic radiation. Visible light, the kind our eyes can detect, is merely a very small portion of this vast electromagnetic spectrum. This spectrum includes everything from radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays, most of which are completely invisible to us.
We're swimming in it, but only see this tiny bit.
Exactly. And here's a surprising fact. Every single thing around us, whether it's glowing hot like the sun or just sitting there at room temperature like your coffee cup, actually emits or reflects some form of this electromagnetic radiation to a greater or lesser extent.
Wow. Okay.
It's truly all around us, constantly in forms we can and cannot perceive.
And if we connect this to the bigger picture, it becomes even more profound. Visible light is indeed nearly a sliver, yet it's the one that dictates our entire visual reality. We perceive it as the entire world, the complete picture.
Right, our reality is just that slice.
Which raises an incredibly important question. What about what we can't see? Our vision, as remarkable and sophisticated as it is inherently limited by our biology. It's a profound thought that our perception of reality, the vibrant world we experience, is only a tiny fraction of what's actually happening in the much larger electromagnetic world. It's almost humbling, really.
It is humbling to think our senses provide us with one very specific yet limited interpretation of existence.
Exactly.
And speaking of biology, let's dive into the miracle of color perception itself, how our eyes act as these incredible, sophisticated light sensors. It all happens within the retina of our eye.
Right, at the back of the eye.
This delicate, light-sensitive layer at the very back of our eyeball contains specialized light sensors, photoreceptor cells, that are remarkably adept at detecting different ranges of light frequencies. Our source material specifically highlights the critical connection to the red, green, and blue parts of the spectrum.
The RGB cones, basically.
Yes. These aren't just arbitrary colors. They are the foundational wavelengths of light that our eyes process, forming the basis of all the other colors we perceive.
Exactly. And it's not just about broad categories like red or green. Each specific color we perceive in the visible spectrum actually corresponds with light of a particular, very precise wavelength.
Like musical notes.
That's a great analogy. Think of it like different notes on a piano.
Yeah.
Each note has a specific frequency, and light works similarly, with each color being a distinct note or wavelength on the electromagnetic spectrum. So when you see a vibrant green leaf, your retina is detecting light waves within a very specific, narrow wavelength range that your brain then interprets as green. It's an incredibly precise and efficient system.
Okay, so to really drive home this idea of varying perception and, well, the limitations of our own vision, let's think about how other creatures experience light. Our source gives a fantastic example, a honeybee.
Ah, the bees, yeah.
For us humans, ultraviolet rays, that UV spectrum from, say, 200 to 400 nanometers, are primarily a sunburn hazard, right? We literally cannot see them. They're invisible to the human eye.
Can't see them at all.
But for a honeybee, that's a fundamental part of their definition of light. They can see ultraviolet light.
Which changes everything for them.
Totally. It means a flower that looks uniformly yellow or white to us might appear completely different to a bee, revealing intricate patterns, nectar guides, UV-absorbing areas, stuff that's entirely beyond our perception.
It dramatically illustrates the concept, doesn't it? Varying perception based on physiology, on evolution.
It really does.
And it forces us to consider the profound implications.
Sure.
What else might other creatures see or sense that we don't? How does this expand or even fundamentally challenge our understanding of what reality truly is?
Yeah.
It reminds us that our visual world, rich and detailed as it is just one possible, limited interpretation of the immense electromagnetic information surrounding us.
It's humbling. Our perception isn't the only one, or the complete one.
Not by a long shot. Makes you wonder what an alien life form with different visual receptors might see out there.
It truly is humbling. So, okay, if we can only see such a small part of the entire electromagnetic spectrum, how do we then get all the vibrant, incredible colors we do see? You know, from the deep purples to the fiery oranges.
Right, good question. How do we make sense of that limited input?
Well, this brings us to the fascinating dance of color. Additive, subtractive, and what our source calls reflective magic. It points out that all other colors, literally every other hue you can imagine, can actually be produced by combining light of those three primary colors we mentioned earlier, red, green, and blue, in various precise amounts.
Varying the mix.
Exactly. And this is absolutely crucial for understanding things like the digital screen you might be staring at right now.
And this combination principle leads us directly to a fundamental concept: additive color. The source explains that when you combine all three of these primary colors, red, green, and blue, in equal amounts, they combine to give white light.
White light.
This is the core principle of how light itself generates color. You're adding light together, and the sum of all visible wavelengths is perceived by our eyes as white.
Adding light makes it lighter, heading towards white.
Precisely. Think of it like a symphony where all the instruments playing together create a rich, full sound. Additive color is like adding instruments of light.
Which brings us to a really interesting and sometimes confusing distinction. RGB versus CMYK.
Yes, the two big models.
They're two fundamentally different worlds of color creation, right? Even though they both deal with how we perceive hues. Let's start with RGB, red, green, blue.
The additive one.
Yes, this is what we call additive color, and it's the model used for anything that emits light, like your computer screen, your TV, your smartphone, or even stage lighting.
Things that glow.
Exactly. The key here is the more light you add, the lighter and brighter your color becomes. Imagine shining red, green, and blue spotlights onto a white wall in a dark room. Where they overlap, they create new colors.
Cyan, magenta, yellow.
Right. And where all three perfectly overlap, you get that pure, bright white. Each pixel on your screen is essentially a tiny little cluster of red, green, and blue light emitters, precisely controlled.
Millions of tiny lights mixing together.
But in stark contrast, we have CMYK.
Cyan, magenta, yellow, and key, which is black.
Right. And this is the subtractive color model, used mostly for printing.
On paper, usually.
Yeah. Here, it works precisely the opposite way. Instead of adding light, you're adding pigments, dots of ink, onto a white surface.
Pigments that absorb light.
Exactly. These inks work by absorbing specific wavelengths of light and reflecting others. The more ink you put on the paper, the more light is absorbed.
So the darker it gets.
Right, and therefore the darker the colors become, eventually resulting in black when all inks are combined, or close to it. Think of it like mixing paints. The more colors you add, the murkier and darker the mixture gets.
Because each pigment is subtracting more light from what gets reflected back. It's taking light away.
So whether you're staring at your phone screen right now, enjoying those vibrant, glowing images, or holding a beautifully printed magazine with rich, deep colors, you're interacting with these two fundamentally different yet equally ingenious ways of creating color. Additive for light, subtractive for print.
It's pretty neat when you break it down.
Okay, here's where it gets really interesting and maybe a bit mind-bending. Understanding how everyday objects themselves get their color, it's all about selective reflection.
Right. Why is that apple red? Our source clarifies this perfectly. We perceive the color of an object when light of mixed wavelengths, like white daylight, which contains all the colors.
Okay, mixed light hits the object.
And is reflected selectively into the eye from the surface of the object. It's a crucial distinction. The object itself isn't inherently red in the dark.
Oh, right. No light, no color.
Exactly. Rather, it has a physical structure, molecules on its surface, that interact with light in a specific way and that makes it appear that color to us, but only when it's illuminated.
Let's use some specific examples to really illustrate this. Take a white porcelain bowl. Our source tells us it looks white because its surface is designed to reflect all the wavelengths from all parts of the visible spectrum, the reds, greens, and blues equally and efficiently.
Bounces everything back.
Pretty much. This mixture of all colors, reflecting back and reaching your eye, appears white.
Now consider a vibrant red armchair. This armchair looks red to your eyes because its fabric specifically absorbs most of the blue and green light waves that hit it.
Soaks them up.
Right. But it selectively reflects only those waves that fall into the red part of the spectrum. So the blue and green light waves are absorbed by the material, while only the red ones make it back to your eye, signaling red to your brain.
So it's reflecting the red, absorbing the others.
Precisely. This concept of selective absorption and reflection is absolutely key to understanding the entire visual world around us. It's how virtually every colored object you see, from a bright yellow taxi to a deep purple flower, gets its distinct hue.
Wow.
And it explains why if you put that red armchair in a room lit only by pure blue light, it would appear almost black or a very dark, dull shade because there would be no red light available for it to reflect.
Whoa, okay. That makes sense. The light source matters just as much as the object.
Absolutely critical.
So, okay, now that we've got a grasp on what light is, how it fits into the broader electromagnetic spectrum, and how we perceive its incredible range of colors through these processes, additive, subtractive, selective reflection. Let's pivot.
Right, let's move from the what to the how.
Exactly. Let's transition to how light actually behaves in a space. This is where we unpack light's predictable behavior, the fundamental blueprint for design. Lighting design, as our source emphasizes so clearly, isn't some mystical art. It is possible precisely because light is predictable.
That's the foundation. It follows rules.
It obeys certain fundamental laws, and it exhibits certain fixed characteristics every single time. It's not random or chaotic. It's a measurable, controllable, and therefore manipulable force.
And this predictability is precisely why lighting design can be such a powerful tool. However, it raises an important question. If light is so predictable, why is designing with it so complex? Why do so many spaces feel, well, badly lit?
Yeah, that's a good point.
It's because the challenge for the lighting designer isn't just about turning on a bulb or pointing a fixture. It's about understanding and expertly applying light within a given space or onto a specific subject.
It's orchestration.
Exactly. It's about orchestrating a complete visual experience, considering not just basic illumination, but also mood, the intended function of the space, and its overall aesthetics. This requires a deep, nuanced understanding of light's subtle qualitative properties and how they interact. It's more than just brightness.
And our source lays out 8 absolutely key factors that govern the application of light. These are essentially the main tools in a designer's toolkit.
The levers they pull.
Right, they are. Reflectance, transmittance, diffuseness, brightness, contrast and shadow, glare, light form and texture, and of course color.
Quite a list.
It is. And these aren't just academic terms. They are the levers designers pull to create real impact. We're going to dive into each of these in detail, starting with reflectance. Reflectance. Okay, so our source defines it as having to do with how light reflects off surfaces, and critically, how that affects the distribution of light within a room.
So not just the light source, but how everything else reacts to it.
Exactly. It's a fundamental concept because it's not just about the lamp itself, it's about how every surface in a space, walls, ceiling, floor, furniture, interacts with that light, absorbing some, bouncing the rest. And this interaction radically changes how a room feels and looks.
And there are 3 distinct types of reflections that are crucial for designers to understand and master. First, we have specular reflection.
Okay.
It's described as mirror-like. This type of reflection occurs when light hits a very smooth, highly polished surface, like a mirror, a sheet of polished metal, or maybe a high-gloss tile.
Oh, like that glare off a car bumper?
Exactly like that. It causes the source of light itself to be seen by reflection, and because the light rays bounce off at the same angle they hit, it frequently causes glare and can create harsh, focused reflections.
Right, that direct, often intense bounce that can be quite jarring. Okay, what's next?
Then you have diffuse reflection. This is where light is spread in many directions from a rough, flat, or matte finish.
So like a painted wall, a standard painted wall.
Perfect example. Our source says it's easy to the eye, and it effectively reduces glare. Imagine that wall painted with a matte finish, or maybe a textured fabric. When light hits it, instead of bouncing off in one direction like a mirror, it scatters.
It spreads out.
In all directions, creating a soft, even, and much more comfortable illumination. This is the kind of reflection that bathes a room in a gentle ambient glow, much less harsh.
Okay, so specular is mirror-like and harsh. Diffuse is scattered and soft. Is there anything else?
And finally, there's combined specular and diffuse reflection. This is often the reality in most environments, right? Where a surface exhibits properties of both.
Like a wooden table, maybe? With a bit of sheen?
Exactly. A slightly polished wooden table might have a subtle sheen, that's the specular part, but also diffuse light in other directions due to its grain and texture. The source points out that the intelligent control of surface finish is often used specifically to manage glare problems and achieve a desired lighting effect.
Ah, so designers choose finishes carefully to control this.
Precisely. It highlights the designer's ability to manipulate surfaces to achieve a precise balance of reflection, actively managing how light interacts with and fills the space.
These concepts have incredibly practical implications when it comes to design, especially in terms of the colors we choose for our interiors. Our source gives some really concrete examples for reflectance based on color.
Like the percentage of light bounced back.
Exactly. A white painted surface, for instance, typically has a reflectance of about 70%.
70%? That's a lot.
It is. It bounces back a large majority of the light that hits it. Compare that to a cream-colored surface, which has about 60% reflectance.
Still pretty high.
But then look at a green-colored surface, significantly lower, down to about 40%.
Okay, so color choice massively impacts how much light stays in the room.
Massively. It means it's not just about what color you see on the wall, but how much light that color is actually bouncing back into the room. A white room genuinely feels brighter, more expansive, and more open.
Because it is brighter. It's reflecting more light.
It is. It's not just a visual trick. It's a measurable physical property at play. This is why, if you're trying to save on your electricity bill, simply choosing lighter paint colors can literally make your home feel brighter without adding a single extra light fixture.
That's a great practical tip. A passive energy-saving design choice.
Totally.
And these design considerations extend significantly into interiors, particularly when thinking about how light is distributed in different sized rooms. This is where the ceiling and floor become surprisingly active participants.
Right, not just passive surfaces.
Definitely not. In large rooms, for example, think a convention hall, a large open-plan office, or a museum gallery, the walls actually have much less importance than the ceiling when it comes to achieving a good overall lighting level.
Really? The ceiling is more important than the walls in big rooms.
For overall distribution, yes. To effectively illuminate such a large space, the ceiling must efficiently reflect light downward into the middle of the room. This means giving the ceiling a high reflectance finish, typically a bright white or very pale color, is absolutely crucial.
And a dark ceiling.
A dark-toned ceiling in a large room will literally soak up light like blotting paper. It makes the space feel significantly dimmer and requires much more artificial light to compensate, regardless of how many fixtures you install.
Wow. Okay, so in large spaces, the ceiling is like a giant reflector. But what about smaller rooms? Does it change?
It does shift quite a bit. Our source says that in a small room, say, a cozy bedroom or a compact living area, pale walls will often be sufficient to maintain an adequate distribution of light.
So the walls do more work proportionally.
Kind of, yeah. So in that more intimate context, a dark ceiling may actually be chosen for purely aesthetic or psychological reasons, perhaps to create a sense of intimacy or coziness without drastically compromising overall light levels.
Interesting. So the rules adapt to the scale.
They have to. And this also critically brings natural light into the calculation. You can't just think about artificial light.
Right, windows change everything.
In the thoughtful planning of a room's color scheme, natural light should always be a primary factor. If sunlight primarily comes into a room solely from side windows, perhaps from a south-facing wall, a dark ceiling might indeed cause the room to look quite gloomy because it's absorbing the very light that's entering.
Makes sense.
And crucially, our source states that normally, a pale floor covering is highly desirable to reflect window light entering a room obliquely.
The floor, reflecting window light.
Yes. This is a subtle but remarkably powerful design tip. Your floor isn't just something you walk on. It's an active, impactful participant in illuminating your space, especially when integrating natural light from windows. It bounces that light deeper into the room.
I never really thought about the floor that way.
Most people don't. Which raises an important question. How often do we truly consider the ceiling and floor as active participants in lighting a space, rather than just focusing on the light fixtures themselves?
Yeah, probably not often enough.
It's not just about what's emitting light, but what's reflecting and distributing it. It's a complete interconnected system. Understanding these principles is fundamental to achieving truly effective and comfortable interior illumination. Every surface matters, every color choice has a profound impact.
Every surface absolutely does matter, that's clear. And that leads us nicely into our next crucial qualitative property, transmittance.
Right, moving from reflection off surfaces to transmission through them.
Exactly. Transmittance, simply put, is the ratio between the incident light, that is, the light hitting an object, and the light that is actually transmitted through that object.
So how much light gets through, basically?
Essentially, yes. How much light passes through something, and importantly, how it does so. Think about holding a clear glass window pane versus a frosted glass shower door up to the light.
Very different effects.
Fundamentally different ways they interact with light, influencing both visibility and privacy.
The source meticulously outlines various types of light transmittance, which helps visualize these differences. First, you have direct or non-diffuse transmission.
Direct transmission, okay.
This is where light passes through clearly with minimal scattering, just like through a perfectly clear pane of glass or still water. You can see right through it. Image is undistorted. Simple.
Okay, clear glass. Got it. What's next?
Then you have semi-diffuse transmission. With this, light passes through, but it is somewhat scattered.
Like frosted glass.
Exactly like frosted glass, or maybe a translucent window blind, or even a semi-sheer curtain. It allows light to penetrate, but it distorts or blurs the image.
Creating privacy, but still letting light in.
Precisely. It gives you ambient light without full visibility.
Okay, then there must be fully diffuse.
Yes, diffuse transmission. Here, light passes through and is widely scattered in all directions. Think of a rice paper lantern, or a fabric diffuser on a light fixture, or a heavily frosted pane of glass.
So you can't see through it at all, it just glows.
Correct. The light is completely dispersed, no clear image is visible through the material, it simply glows. And finally, you have partial diffuse transmission.
A mix.
Kind of. It's often a combination of direct and diffuse transmission. Some light passes directly through, while some is also diffused. offers a versatile middle ground.
So think about a privacy screen in an office, or a decorative glass panel in a doorway, or even the material used in a modern lampshade. They're not just static barriers, they're actively shaping the light coming through the space, controlling how much passes and in what manner.
So what does this all mean for design?
Well, it means designers can meticulously choose materials not just for their appearance, but precisely for how they will filter, scatter, and distribute light within a room. It profoundly affects both visual comfort and privacy.
They're designing with light as a material, in a way.
Exactly. Which brings us to a closely related, equally critical concept, diffuseness.
Diffuseness?
Yeah.
Okay, how's it that different from diffuse transmission?
Good question. Diffuseness is formally defined as the degree to which light is shadowless due to its directivity as it impinges on a particular point of the object relative to the light intensities.
Okay, that's a bit technical.
It is. In plain English and more intuitively, it simply describes how soft or hard the light is in a space generally.
Ah, soft light versus hard light. Got it.
Imagine a very diffused light source, like a heavily overcast sky. It creates almost no discernible shadows, right? Everything's bathed in a gentle, even glow.
Flat light almost.
Kind of. Conversely, a highly directional, concentrated light source, like a single powerful spotlight, creates sharp, deep, and clearly defined shadows. Hard light.
And how do we judge this quality in practice? Just by looking.
Our source tells us it can be judged directly by the depth and sharpness of shadows.
Makes sense.
If you're in a room with a lot of ambient, indirect light, perhaps bouncing off a white ceiling or coming through a large diffused window, you'll notice very soft, barely perceptible shadows, if any at all. Soft light.
Right.
But if you have a single, strong, focused spotlight on an object, the shadows will be stark, sharply defined, and very clear. Hard light, sharp shadows.
What's truly fascinating here is how diffuseness directly impacts our ability to perceive form and depth.
But how so?
Well, a very diffuse, shadowless light can actually flatten an object, visually speaking. It can make it appear two-dimensional and obscure its contours because there are no shadows to define its shape.
Okay. Like on a really overcast day, everything looks less three-dimensional.
Exactly. On the other hand, a directional light with its accompanying shadows accentuates an object's contours, textures, and three-dimensional form. It gives it volume and presence.
So shadows are key for seeing shape.
Absolutely.
Ah.
Diffuseness, or the lack thereof, is a key tool in guiding the eye, emphasizing specific elements within a space, and creating drama or subtlety depending on the designer's intent. It's the difference between a flat photograph and a sculpted bust, really.
Okay, moving on to another critical trio in how we perceive our environment: brightness, contrast, and shadows. These three are really fundamentally intertwined in creating a comfortable and functional visual experience.
They work together closely.
Definitely. Starting with brightness, our source defines it as the attribute of visual perception in accordance with which a surface appears to emit more light or less light.
So basically how bright something looks to us.
Pretty much. It's essentially how luminous or radiant something appears to our eyes, how much light it seems to be giving off or reflecting.
It's also sometimes called the accent factor, right? Because brighter areas naturally draw our eye. They grab our attention.
Exactly. Our eyes go right to the bright spots.
And when designing for visual comfort and efficiency, achieving a harmonious viewing experience is paramount. Our source specifically recommends a brightness ratio of 3.1 between the object being viewed and its immediate background.
3-to-1. Why that specific ratio?
It's a researched guideline. It helps ensure visual comfort, reduces eye strain, and optimizes focus, especially for prolonged tasks like reading or working at a computer. Too much difference, and your eyes get tired quickly adapting.
Okay, so not too bright, not too dim relative to the background.
Right. And to achieve this comfortable brightness balance, the source says it is highly desirable to limit luminance ratios between areas of appreciable size as seen from normal viewing positions.
Which basically means?
In everyday terms, it means extreme differences in brightness between different large parts of your visual field can be incredibly uncomfortable or even jarring.
Like having a super bright spotlight on your desk while the rest of the room is pitch black.
Exactly. Your eyes would constantly struggle to adapt back and forth, leading to fatigue. You don't want that constant adjustment. It's about creating a balanced visual environment where your eyes can relax and focus without unnecessary strain.
Makes sense. Which leads directly into the next concept, contrast.
Right. Contrast is fundamentally the difference in luminance. But it specifically refers to the brightness ratio that is compatible with the clear delineation of outline, size, and details of the task area. Importantly, in the absence of any form of debilitating glare.
So contrast helps us see details clearly.
Precisely. It's what allows us to distinguish one object from another or to read text effortlessly. Think about reading sharp black text on pristine white paper. The high contrast makes it incredibly easy to read.
Yeah, super clear.
Now imagine trying to read light gray text on a slightly off-white paper. The low contrast makes it much harder to distinguish the letters and leads to quick eye fatigue.
Ugh, yeah, that's hard work. So contrast is essential for legibility and perception of form.
Absolutely.
Okay, and then there are shadows. Shadows are often overlooked, maybe even seen as just an absence of light.
But there's so much more.
They really are. They are an absolutely fundamental and profoundly important aspect of the visual field. They are critical because they enable the observer to discriminate between various forms, judge distances, and accurately ascertain the relative position of objects in three-dimensional space.
They give us depth cues.
Totally. Without shadows, everything would look completely flat, like a two-dimensional drawing. They're like the unsung heroes of visual perception, giving dimension, depth, and crucial spatial information to the world around us. A room without shadows would feel weirdly disorienting.
Indeed, shadows are far from passive. And several factors profoundly influence their quality, sharpness, and overall impact.
Like what?
Well, both the concentration and the direction of the lighting directly influence the effect. For example, a highly concentrated, very direct light source, like that focused theatrical spotlight we mentioned, will create very harsh, sharply defined shadows. Good for drama.
Right. And a broader light source.
A brighter, more diffuse light source will create softer, less defined shadows. Gentler.
And distance matters too, right?
Huge factor. The farther the lamp is from the object, the softer and more diffuse the shadows will be.
That's a crucial practical tip for designers, photographers, anyone setting up lights. If you want softer shadows, move your light source further away or use a larger source like a softbox.
It's a fundamental principle of manipulating light for desired effects. And finally, our source highlights the most natural and universally comfortable lighting direction we perceive.
Oh, what's that?
It's diagonal from one side, typically at around 15 to 45 degrees to the horizontal.
15 to 45 degrees diagonal. Why that angle?
Because this specific angle and direction correspond precisely to our natural, deeply ingrained experience of daylight coming through a window.
Window light.
This makes it visually comfortable, intuitive, and natural for us to interpret the forms and depths of objects illuminated in this manner. It's how our brains are wired to see the world most easily. It feels right.
That makes perfect sense.
So if we connect this to the bigger picture, shadows are not just an incidental byproduct of light. They are integral to our spatial awareness, depth perception, and even our emotional response to space. They help us navigate our environment, understand relationships between objects, infer textures, and even convey a sense of time. This raises an important question for designers and for us. How can we intentionally use shadows as a creative active element?
Not just something that happens.
Exactly. Not just a passive absence of light, but a tool to shape perception, enhance mood, or even tell a story within a space. They are as much a design element as light itself.
That's a powerful question, thinking of shadows as an active tool. Okay, now let's move on to two more subtle but profoundly impactful aspects of lighting: glare, and then light form and texture. These are about managing comfort and revealing the very essence of materials. First, glare.
Look is right. Glare is precisely defined as a sensation produced by brightness within the visual field that is sufficiently greater than the luminance to which the eyes are adapted.
So basically way too bright compared to everything else.
Exactly. Simply put, glare occurs when your eye has to cope with a light source or a reflected light source that is overwhelmingly brighter than the overall or ambient lighting in a room.
Like walking from a dim room straight into bright sunlight.
Perfect example. That uncomfortable sensation, the painful squinting, that's debilitating glare. It causes immediate discomfort, reduces visibility, and can even impair your vision over time.
Which is why it's such a critical factor for lighting designers to actively mitigate and control. It impacts both comfort and safety.
Hugely important.
It's why those bright, exposed bulbs, especially some modern LEDs that are often super intense, placed right at eye level, can be so irritating in a restaurant or a living room.
Oh, it drives me crazy.
Right. They create incredibly uncomfortable visual experiences, disrupting what could otherwise be a pleasant environment. Okay, so controlling glare is key. Next, we have light form and texture.
Right. Our source clarifies that light texture pertains to the very specific way light is delivered from a source, whether it's primarily directional or primarily diffuse.
We touched on this earlier with diffuseness, but here we're focusing specifically on how that delivery interacts with surfaces and materials.
Exactly. How the light reveals the surface. This is truly where light transforms from a mere illuminator into an artist's tool, actively shaping how we perceive the very surfaces and materials around us.
It's like a secret language between light and material.
That's a great way to put it, where light either whispers or shouts about a surface's inherent qualities. Our source talks about two key approaches: revealing versus concealing material texture.
Revealing or concealing? Okay.
For instance, natural tactile materials like rough stone, exposed concrete, or richly grained wood may benefit immensely from directional light sources.
Why directional?
By creating dramatic shadows through techniques like grazing, where light skins across a surface at a very steep angle, or using steep aiming angles, light can emphasize every ripple, every pore, every knot and grain.
Plus it brings out the texture.
Dramatically enhances the inherent tactility and visual interest of these materials, makes them feel more real, more present.
Okay, that's revealing texture. What about concealing?
Well, on the flip side, if you have imperfect walls, perhaps an older plaster wall with slight undulations, or materials that are specifically intended to appear perfectly smooth and flawless.
Like a modern minimalist look.
Right. They may benefit far more from diffuse sources located further away from the material. Soft, even light.
Why diffuse for that?
This is about aesthetic control. Using soft, even light helps to conceal imperfections and ensure a clean, unblemished, or uniformly smooth appearance. It washes over the flaws instead of highlighting them with shadows.
Wow. It's a testament to how incredibly nuanced lighting design can be. Literally manipulating our perception of surfaces, making them appear rough or smooth just by how you light them.
It's incredibly powerful.
Finally, we arrive at color. Specifically the psychology of light color, that invisible force that profoundly influences warmth, coolness, and our very mood.
The emotional side of light.
Exactly. This is where light truly connects with our deepest emotions and even our biology. Our source states that color can immediately affect the mood and state of mind of a person, depending profoundly on their personal and cultural experience.
It's an incredibly powerful, often subconscious influence.
Yeah, few people probably consciously recognize it day to day.
This is absolutely true, and it's a cornerstone of thoughtful lighting design. Think about the immediate distinction between warm and cool lighting colors. Warm lighting colors, those that lean towards yellow, orange, and red tones.
Like firelight or old incandescent bulbs.
Exactly. They tend to elicit a homely, calm, and relaxed surrounding. Imagine a cozy evening in a living room, bathed in soft, yellowish light. It instantly creates a sense of comfort, intimacy, and ease.
Feels safe, comfortable.
Right. It's not just aesthetic. It's rooted in our primal associations with warmth and safety.
And conversely, cool lighting colors.
Those that lean towards blue, white, and even slightly greenish tones, often found in natural daylight or modern fluorescent LED lights, they tend to elicit activity, promote alertness, and create a productive pace.
Like in an office or a hospital.
Perfect examples. Think of bright office spaces, clinical hospitals, or even high-energy retail environments. They often use cooler, bluer-toned light to stimulate focus, enhance visual clarity, and promote efficiency.
Interesting. So the light color is sending signals.
Constantly. What's fascinating here is how our biological responses, our circadian rhythms, and our deep cultural associations are intrinsically linked to the color of light.
It's not just aesthetics.
Definitely not. It's a strategic choice that can profoundly influence how we feel, how productive we are, and even how we behave in a given space. This is why you'll rarely see warm, cozy lighting on a high-intensity trading floor, or stark, cool white light in a restaurant aiming for intimacy. The light itself is strategically setting the expectation. Designers leverage this psychological impact all the time.
Wow. Okay, this also extends to the crucial art of complementing material color, right? Matching the light to the stuff in the room.
Absolutely. Our source provides some fantastic practical guidance here. Cool colored materials like blues, greens, cool grays, or even certain metallic finishes in a room. They can be significantly emphasized and truly brought to life by cool light sources. Think of cool fluorescent bulbs, metal halogen lamps, or certain modern LEDs. These lights enhance the inherent coolness of the materials, making them appear more vibrant and true to their intended hue.
Makes the cool colors pop.
Exactly. And conversely, warmer, richer materials such as natural wood, textiles with earthy tones like terracotta or burnt orange, or even certain warmer stone finishes tend to benefit greatly from warm light sources.
Like incandescent bulbs or warm LEDs.
Right. These lights bring out the richness, depth, and inherent warmth of the colors in the material, enhancing their natural beauty and making them feel more inviting. It makes wood look richer, warmer.
Okay, match cool light to cool materials, warm light to warm materials. Seems simple enough.
But there's an important caveat here, a critical nuance that our source highlights.
Oh, what's that?
Keep in mind that warm fluorescent sources often appear warm to the eye, but actually do a poor job of rendering warm materials.
Wait, really? A warm-looking fluorescent might not make warm things look good.
It's true. This is a vital practical application insight. Just because a light source looks warm doesn't necessarily mean it accurately represents or enhances all warm colors well. This gets into something called a color rendering index, or CRI.
CRI. I've seen that on bulb packages.
Right. It's a technical quality, not just perceived warmth. It reminds us that perception can sometimes be deceptive, and true color rendering is a specific technical quality that designers must consider. It's why sometimes a room can feel warm, but your skin tone in the mirror looks kind of off.
Huh. Okay, that's a really important distinction. Good to know.
And to help us understand this in a more quantifiable and consistent way, the colors of electric lamps are typically subdivided into three main groups, related by their color temperatures, which are precisely measured on the Kelvin scale, K.
Okay, the K number's on the box.
Exactly. You have daylight white, which is typically around 6,000 Kelvin, maybe 5,000 K to 6,500 K. This is a cooler, bluer light, very similar to natural daylight at noon on a clear day.
Bright and bluish. For alertness?
Generally, yes.
Okay.
It promotes alertness and is often used in task-oriented environments or places where true color accuracy is paramount, like studios or workshops.
Okay, then what's next?
Then there's neutral white, usually around 4,000 Kelvin.
Mm-hmm.
This is a more balanced white, falling between warm and cool. A bit crisper than warm white, but not as blue as daylight.
Kind of a middle ground. Where would you use that?
Often used in commercial settings, offices, kitchens, maybe general task-oriented settings where a clear yet not overly harsh light is desired.
Okay, and the last one, the cozy one.
And finally, there's warm white, typically around 3,000 Kelvin, or sometimes even lower, like 2,700 K. This is the warmer, yellower light we often associate with traditional incandescent bulbs, candlelight, and cozy home environments.
Like living rooms, bedrooms.
Exactly. This is the light that signals comfort and relaxation. So you see 3,000 K or 4,000 K or 6,000 K on a light bulb box at the store.
Mm.
You're now armed with the knowledge of what kind of mood, energy, and effect that light is specifically designed to create. It's like having a superpower for understanding and intentionally designing your home or office space.
It really is, allowing you to fine-tune the emotional and functional feel of any room just by choosing the right bulb temperature. Hashtag outro. And there you have it, a truly illuminating deep dive into the fascinating, complex, and deeply impactful world of light.
Oh, wow. It's a lot, isn't it?
It is. We've journeyed from its fundamental nature and how our incredible eyes perceive color through that intricate dance of selective reflection, all the way to its predictable qualitative behaviors.
Reflectance, transmittance, diffuseness.
Brightness, contrast, shadows, the critical issue of glare, and how light shapes both form and texture.
But we also dug into the profound psychological impact of light color on our mood and state of mind.
Revealing just how much light truly dictates our daily experience, often without us even noticing.
Indeed. We've seen that light is far more than just illumination. It is predictable, measurable, and profoundly manipulable.
Which is why design is possible.
Exactly. By understanding these intrinsic properties, you gain a truly deeper appreciation for the visual world around you and the incredible intentionality behind every aspect of thoughtful lighting design. Whether it's in your home, your office, a museum, a retail space, or even vast public areas.
Mm-hmm.
Knowledge is most valuable when understood and applied.
Yeah.
Hopefully this deep dive has given you a completely new lens through which to view your illuminated world.
Letting you see the invisible forces shaping your reality.
Nicely put.
So what does this all mean for your space, your vision, and your day-to-day experience?
Yeah, how do you take this home?
Considering all we've discussed about how light impacts mood, perception, and even our biology, what subtle, perhaps even surprising changes could you make to the lighting in your own immediate environment, maybe your desk, your living room, or even your kitchen? Changes to enhance your well-being, boost your productivity, or simply create a more comfortable atmosphere.
It's worth thinking about. Even small changes can make a difference.
We challenge you to look at light differently from now on, to truly see it as a design element, not just an afterthought.
Start noticing the light around you.
Thank you for joining us on this illuminating deep dive. Keep observing the subtle yet powerful effects of light around you.
Stay curious.
And we'll catch you next time on The Deep Dive.